The largest volcano of all time just cracked open the Earth. While natural disasters such as hurricanes and tsunamis are terrifying, volcanoes are horrifying. Of course, they aren't merely mountains spewing molten rock. Volcanoes are raging messengers of death and destruction that erupt from the Earth's core. There are estimated to be 5 to 10 volcanoes capable of a super-eruption with disastrous consequences for the biosphere. One of these volcanoes, buried beneath Lake Toba in Sumatra, has erupted twice in the last million years. Is this supervolcano about to re-erupt? What are the odds of survival if it happens? A massive supervolcano lurks beneath the calm waters of Lake Toba on the Indonesian island of Sumatra. Only a few volcanoes, like this geological monster, are capable of super-eruptions that might severely affect the climate system for an extended time. So, how do we know when the next supervolcano will erupt? Indonesia is between the Indian and Pacific Oceans, Southeast Asia and Oceania. Indonesia has over 17,000 islands, including Sumatra, Java, Sulawesi, and parts of Borneo. Sumatra is Indonesia's third largest island. Lake Toba, a vast natural lake located in the caldera of a supervolcano that may be the largest volcano on the planet, is located in the district of North Sumatra in the country's north. Aside from the supervolcano, the entire topography of Indonesia is filled with volcanoes, formed by subduction zones between the Indo-Australian plate and the Eurasian plate. Some of the volcanoes are well known for their eruptions. The massive Krakatoa volcano was known for its global effects in 1883. The Lake Toba Caldera volcano is known for its supervolcanic eruption, which is considered to have occurred 74,000 years ago and caused 6 years of volcanic winter, and the volcano Mount Tambora for its catastrophic eruption in 1815, which is the most destructive eruption in recorded history. The volcano beneath Lake Toba has been the focus of an international team of geologists' inquiry into possible early indicators of such a catastrophic eruption. This volcano unleashed two of the most massive eruptions the Earth has ever seen, roughly 840,000 years ago and 75,000 years ago, respectively, releasing an estimated 670 cubic miles of ash and lava. Each eruption produced enough ash to shroud Switzerland in an ash layer 7 centimeters thick. Because there has never been an eruption of this size accurately recorded in human history, this investigation is critical to know how we might be affected and how we might respond. Present-day Lake Toba is situated among the remains of the caldera. Toba is at least 1.3 million years old, and after its super-eruption around 75,000 years ago, it had at least 6 different eruptions, and most likely more. The most recent eruption we've uncovered occurred roughly 56,000 years ago, but there could have been others that have yet to be discovered. Although the impacts of the supervolcano eruption on human evolution are unknown, some scientists believe it caused a catastrophic ice age that nearly wiped off modern humans. According to Ice Core statistics, the average worldwide air temperatures plummeted by 3 to 5 degrees Celsius for years after the eruption. According to some model estimates, the Northern Hemisphere's temperature may have plummeted by up to 10 degrees Celsius in the first year after the volcanic eruption. Anthropologist Stanley Ambrose linked the Toba eruption to modern humanity's low genetic variety in 1998. According to genetic evidence, the human population collapsed around 74,000 years ago, with only a small number of survivors giving origin to all current individuals. According to the Toba catastrophe theory, only a small number of early humans with minimal genetic variation survived by chance in Africa, whereas the most of early people in Europe and Asia died as a result of the Toba eruption's abrupt changes in temperature and environment. However, archaeology and paleoclimatology findings do not appear to support this notion. Magma is what causes supervolcanoes to erupt because it builds up beneath the crust in the mantle, unable to break out until the pressures are so high that the entire system blows up. According to Luca Carici, co-author from the University of Geneva in Switzerland, the first super-eruption occurred around 840,000 years ago after 1.4 million years of magma accumulated, whereas magma fueled the second super-eruption around 75,000 years ago after only 600,000 years of magma accumulation. Both eruptions were on the same magnitude, but the second one built up its magma faster, according to the experts, since magma warms up the continental crust surrounding the volcano over time, keeping the magma hot for longer. The more magma heats the crust, the slower it cools and the faster magma accumulation rises, generating a vicious cycle of eruptions that can increase the frequency of super-eruptions over time. They transition to more localized and regional hazards such as landslides, tsunamis, earthquakes, and volcanic eruptions, which can occur often for tens of thousands of years. The good news is that the next massive super-eruption on Toba will not occur for another 600,000 years, according to researchers. What's the bad news? Before the eruption, there will be no unusual geological markers. We won't even be aware of its impending arrival because the buildup will be gradual and silent. To reach these conclusions, the researchers examined the quantities of lead and uranium and zircon, a small crystal found in volcanic rocks. According to previous research, zircons can be used to quantify the volume of magma trapped beneath volcanoes. As one of its characteristics, zircon absorbs uranium and incorporates it into its structure. Scientists can determine the age of zircon by measuring the amount of uranium and lead in the zircon with a mass spectrometer as uranium decays into lead over time. The team dated zircons from multiple Toba eruptions, with the most recent zircon revealing the eruption's date and earlier ones showing how magma formed. The zircon dating method enabled scientists to estimate the volume of magma boiling beneath the surface of the Toba volcano. According to Karichi, the reservoir of the Toba volcano contains approximately 320 cubic kilometers of magma. At Toba, the eruption seemed to have continued for at least 15,000 to 20,000 years after the super-eruption. The researchers also estimated the history of structural adjustment at Toba by using carbon-14 dating of lake sediments that have been lifted to 600 meters above the lake in which it developed. According to these statistics, structural adjustment lasted at least 30,000 years before ceasing roughly 2,000 years ago, and it may still be occurring today. This structural adjustment appears to have continued until a few hundred years ago and is possibly still ongoing today. It is the magmatic equivalent of aftershocks from an earthquake. According to scientists, a supervolcano poses threats even after it has erupted. Following a supervolcanic eruption, the volcano and magmatic system must work together to restore balance, much like a body of water that has a boulder thrown into it. This procedure is time-consuming. Today, Toba is still alive and boiling. This is the first time scientists have been able to understand what happens after a supervolcano explodes. According to the Volcano Explosivity Index, for an eruption to be considered a supervolcano, it must be at least magnitude 8, with measured deposits of more than 240 cubic miles. Toba erupted with a volume of magma 28,000 times more than Mount St. Helens eruption in Washington state in 1980. Because of its enormity, it created a long-lasting volcanic winter on Earth, possibly causing a bottleneck in human evolution. Other well-known supervolcano locals include Yellowstone National Park in the United States, Topo Caldera in New Zealand, and Campi Flegrei in Italy. The study also showed that Mount Sinabung, which is now erupting and differs from other volcanoes in Sumatra, has the same zircon crystallization history and chemical fingerprint as the magma in Toba system. This suggests that the Toba system is a larger sized and more extensive than previously thought. According to the author, our data imply that Mount Sinabung's recent and ongoing eruptions are a result of the Toba system's ongoing recovery after the super-eruption. The researchers emphasize that the discovery of the link does not mean that the Toba caldera is in imminent danger of a catastrophic eruption. According to researchers, this is most likely business as usual for a recovering supervolcano. These findings also emphasize the significance of performing the more extensive inspections of the location regularly to image the magma system and measure ground uplift. And on that note, we have come to the end of this video. How much do you think civilization will be affected by a supervolcano eruption today? Let us know what you think in the comments section. Do not forget to give this video a thumbs up, smash the subscribe button, and turn on that notification bell to get notified when we post a new video.